Yeah, Nimesh. How's it going?
मैं इसको कट करूंगा, थोड़ा एडिटिंग चाहिए. Hi everyone, welcome back to the chat with devs. With me, I have Leon today. Hi Leon, hope you are doing well.
Yeah, Nimesh. Yeah, Nimesh. I'm good. How are you?
I'm doing good. Would you like to introduce yourself to our audience?
Yeah, sure. So, hi everyone. I'm Leon. I work as a customer success engineer at Solar.io, mainly working with Kubernetes, Istio, and service meshes, uh, and also home labs and all. But yeah.
What you're doing is a very the introduction I think did not justify what amazing stuff that you are doing. But will everyone will get to know about what you do, what your expertise is after this session, hopefully. So let's dive into today. You will be teaching us about ambient mesh and the Istio ambient mesh that recently went. I think they launched the recent version about its update as well, right? So let's get started.
Yeah. So Istio recently released the ambient mesh in a beta state. So basically, that means that consumers can now run it in production, basically as a beta version. It's not fully stable, so there will be bugs, but many people run uh, things like betas in production these days just as a testing phase.
Right.
So yeah, so to get started, basically HTO is something that was a de facto service mesh and also had this concept of sidecars. So the way HTO used to work was each application in Kubernetes in the cluster would have like a sidecar running. So using that, they could basically do things like L7 processing, L4 traffic, and L7 was together in one sidecar. Ambient sort of tries to decouple that, and with that we can like not have sidecars and reduce a lot of cost. So yeah, this is like just a small about me. If anybody wants to connect with me, you can scan this QR code. I'm Mediocre DevOps on Twitter and LinkedIn URL is there down. Biodrop link might expire in 2 weeks, I think. They shut down. So sort of have to migrate from that also. But yeah. And yeah, so do you have any like starting questions or anything, or like should I just go on?
So I have one. You mentioned before Istio used to have a sidecar. So and like they went sidecar less with ambient mesh. So like, what's the difference in between them? How did they work? Started working?
So yeah, so the common way of service meshes was they used to transparently do things in the mesh. So basically, you had like an application, for example, you have a blog running, but you also need things like rate limiting and maybe authentication to your blog, right? And your blog itself doesn't have any way of authentication. So developers used to write all this inside the application itself. So from a microservice, it used to become like a full blown application. And
Mm-hmm.
with a sidecar, it used to standardize its networking. Basically, you could do authorization, authentication, all with a sidecar, and your app could just run the block. But with this, what used to happen is, for example, if you have 10 apps, you had 10 sidecars, each
Mm-hmm.
application. And some applications maybe are high traffic, some are like very low traffic, but you would still be allocating resources for these sidecars. And Kubernetes itself initially did not have sidecar support in the sense that HTO wanted sidecar support. Now that is enabled. So now you have sidecar support in Kubernetes itself. It's still not, I think, released globally like GA release, but I think it's a feature request that is now already completed in Kubernetes. So ambient mesh basically doesn't have a sidecar as by default. So by default, something called as a waypoint and a Z tunnel exist, where waypoint does L7 and Z tunnel does L4 traffic basically.
And gotcha. So
So
Yeah. So there's a follow-up question with that. Since now ambient mesh has is by default without a sidecar approach, right? So how do they control traffic, or how do they manage the traffic?
Yeah, so what they have done is basically they have split the traffic processing into two parts. Initially, in the sidecar model, all the traffic was going through the sidecar and to the
Hmm.
sidecar and from the sidecar to the application, right? And then from the sidecar to basically the ingress gateway or the egress gateway, depending on how or where you are routing traffic. With the sidecar less model, basically, you have two different components. One is called a waypoint proxy that does all the L7 related stuff like L7 authorization, virtual service routing, and all that. And you have something called as a Z tunnel, that is a Rust based L4 proxy that runs on every node. So rather than running on every application, you run it on every Kubernetes node that you have, and that's how you like add clusters and all. And the L4 is like just L4 traffic. So by default, you can use a retunnel. So you don't have to like so in a way you don't have to enable your L7 stuff by default. So when you install ambient, right? Usually
Hmm.
before in the sidecar pattern, you had to restart all your applications once you inject the sidecar. Any update would also require you to restart your application, and that could cause like a little bit downtime because there was mostly rollouts that used to happen, not blue green deployment or something like that. So
Hmm.
your app would have a little bit of downtime. People have sort of tried, doing maybe revision based install. So what they do is they have two revisions and then one revision is already running and the other revision like for example if you're on 1.18.1 maybe you have a revision in another namespace on 1.18.2 and then you can like route traffic maybe 50-50, and then as soon as if you routed entire traffic then you could just remove the previous revision basically.
Gotcha.
So with ambient this is all transparent. Like the moment you install ambient you label the namespace and all, your traffic is automatically routed via ztunnel. Your application doesn't have to do anything, no sidecars, nothing. And by default, you get MTLS as soon as you install Ambient Basic.
And understood. I think that's good enough for the starting part.
So yeah, so I mean, microservices is a thing, right? It's been there for like quite some time. So people who deploy it in like large amounts, they definitely know about these challenges on screen, like how to secure service to service communication, timeouts, and all these things. In microservices, network is something that is very volatile, right? It's never
Mm.
nobody ever says, okay, my network is always going to be stable or something like that.
Right.
Even app to app communication basically sometimes could fail. So there was things like retries implemented. Then if you see there are some things like exponential backoff that is implemented in some places where after the retries, okay,
Mm.
then tell the user, hey, I cannot access it basically. And then there is traffic control, right? If you want to maybe add a header, you want to remove a header or something like that, or you want to do traffic routing based on a particular header that is received. So all this used to be either a separate microservice or it was within the application that you were running, which basically your business logic and your application logic were very tightly coupled. That's how sidecars came in the whole picture, where you could split that logic and then use sidecars to sort of route traffic and all that, because it became like a programming interface that that the admins could use basically.
Gotcha.
Yeah. uh
Yep.
so next slide is just introduction to a service mesh. Like what is a service mesh? In specific, it's a programmable framework, allows you to observe, secure, and connect your microservices in a way that your microservice does not have to sit and worry about. doing all the things that it shouldn't have to do, like rate limiting and all that. So yeah, any questions so far or anything as such?
No, not on this part.
Good. Then we can move on. So in short, service meshes have very basic, mostly networking related functions. So one is service discovery. Service discovery in Kubernetes is like the most required thing, right? You do not want to sit and have a domain name that has to be mapped to a separate DNS server that you have to call and all that. Service discovery is like, okay, you have a service. If you call that service, it should automatically route to that application, right? No matter which node it is, no matter what the IP is, you should have the ability to discover another service in the mesh. With that, you also have load balancing where you can, like, you know, if service A receives like 50%, service B receives 30% traffic, you can shift the load between them. Secure service to service is your most commonly called MTLS in HTO, where you have like mutual TLS connection on both sides. So this in your application, it's like having a certificate and an identity within your microservice. So this also is removed from the app and put uh, into your sidecar basically. So or now it is in your ztunnel. So your ztunnel is the one who does the MTLS now. And this is traffic control, shaping, shifting, however you want to route your traffic and all that things. Policy is like just network policies or something like that, or authorization policies where you don't let one app talk to the other unless there's like a header in it or something like that. And then you have your telemetry, that is like open telemetry or something like that. And the last is having an API. Basically, HTO does this one good thing, right? It gives you a Kubernetes CRD that you can just write, okay, I want this, I want that, I want a virtual service, and then you just apply it, and it will automatically create the necessary Envoy configurations in sidecars, and now it is eternal. So you don't have to sit and change a config file, then reload HTO and all that.
Gotcha. Gotcha. There's one doubt I have. It's like, how is ambient mesh different from the service mesh?
So ambient mesh is still a service mesh. The way it works is a little bit different. So for example, if you see this architecture, this is the sidecar pattern in HTO. So each application has a sidecar right here, and then you
Mm-hmm.
have a control plane. Now
Yeah.
what we have done is we have removed these sidecars. Your app runs as a normal application, right? But
Okay.
your nodes will have a ztunnel proxy, and
Oh,
each node will have one ztunnel proxy. So instead of one app having it, each node will have the proxy, and that will sort of do the communication, do the MTLS, all the L4 layer stuff is done via that ztunnel. Your app does not
gotcha.
have to do anything.
Understood. That
So
makes sense.
so it's very transparent. Yeah, it's very transparent in the sense your
It
app
can be
doesn't
called
know.
like a upgraded version of service mesh, kind of.
Yeah, it's more like a, so both sidecars as well as ambient mesh has its
Mm-hmm.
places, but ambient mesh is the more cost cut. Like if you want less cost and all in your cluster, ambient mesh is the one that usually people move to now because there is no more sidecars. So you'll be
Right.
running just one container. Your application is not aware that there's a service mesh. Your application just runs and gets deployed as a uh, normal application. There is no sidecar. There is no injection of a application into your app that sort of causes issues and all that. Because there were a lot of issues with sidecars. For example, some ports were not standard ports and all that, and you wanted your app to sort of bypass connection sometimes. But now
Mm-hmm.
you don't have to do all these things because your app itself doesn't know there's a service mesh. It's that transparent. So yeah, Apple just send normal data traffic, and the traffic is then rerouted using ctunnel. So it's
Gotcha.
as simple as that, I would say. Yeah.
Thanks for explaining.
So
Yeah, that answers my question.
yeah, no worries. Yeah, this is how the normal sidecar used to work. Like you could maybe have a traffic come from a gateway, go to the app, have it MTLS in the cluster, then go to the sidecar of a different app. That sidecar would connect to the service. Service would send data back to the sidecar, then wherever the next hop goes, right? And this is ambient mesh. Ambient mesh is not new anymore. I think it was in 2022 that they announced it, and that time Solo and Google were like the lead contributors. They still are,
Mm-hmm.
and that's when. And in 2023, it was accepted into the CNCF. So it graduated the CNCF in 2023, and now in 2024, I think just few days ago we went beta with the L3 and L7 proxy basically.
Yeah, that's nice.
So yeah. So
So
this
now they're
is
production ready. Ambient
yeah.
mesh be used in production now.
Yeah, ambient mesh in the sense has gone beta, but
Mm-hmm.
the L7 and L4 proxies are ready for production. So basically you can use it in production even though it's beta, but a lot of things are supported. Few things are still not supported. So I have linked the articles as to in the next slides basically. So
Sure, sure.
there it'll show you the article, and if you just scan the QR code, it will take you to the article link where they have described more in detail. So yeah, this is a very high level overview of how sidecar is different from the ambient mesh data plane. So if you notice here, each application has like a proxy, and
Mm-hmm.
here it is one proxy and a lot of applications.
Right, right.
So, so depending on where you fall, these are the benefits basically that it provides, the ambient mesh. But yeah, mostly it's because the mesh is transparent now, and that gives a lot of added benefits because developers don't have to sit and test. Okay, what happens if my
Mm-hmm.
sidecar is added? If the sidecar is not there, does it break? Something like that.
Gotcha, gotcha.
Yeah. And this is how the basically the L4 proxy. So by default, you use an L4 proxy. So you don't have to actually have an L7 proxy unless you need the L7 capabilities of Istio. So all traffic will go through the L4. So example, if your one app is on node A and you want to talk to it on node B, it would go to this ztunnel architecture, the ztunnel proxy, get the MTLS and go to the next node, basically connect to the proxy and then to the application. And the L7 is basically just for all L7 related things like L7 authorization, traffic routing, and all that is all L7. L4 is basically more of uh, your MTLS, then data like telemetry and authorization. The
Mm-hmm.
cool thing about it is it uses the connect protocol. So if you've worked with proxies, uh, L4 to L4 is an edge-borne protocol, which is like I'll show in the next slides. But
Sure, sure.
it basically creates a tunnel, a bidirectional tunnel, rather than just like an HTTP request. So you have a connect protocol that sort of creates like a tunnel between these two where you can send data back and forth. So you don't have to like create a new request every time. You could just have that tunnel that sort of sends data back and forth for that particular request.
Nice. That's
But
amazing.
but yeah. So yeah, this is a cool thing with the ambient mesh as compared to uh the
Traditional stuff.
sidecar where yeah, the
Yeah, that's
sidecar is basically, everything was done by this one thing. So if one of this got
vendor.
infected or something like that, yeah, the entire so the blast radius would be very less. For example, if you're seeing a drawback with the L4 proxy being on each node, right?
Hmm.
With the L4 proxy being on each node, what happens if this one L4 proxy goes down, right? So in that sense, yes, it's still like it can cause your applications to go down, but also you could scale these. Like the L4 proxies can be scaled. They're not with the applications. Whereas if you had to scale here, you have to scale both the proxy as well as your application, basically.
Application, right? Yeah. Both were like in the first sidecar approach, both would go side by side. We have to scale them side by side. Rather than here, we can just scale our application and then L4 proxies later, or just once.
Yeah, it's more tightly coupled in the sidecar than the ambient sort of mesh. Yeah, this is the very same thing. It just gives you an overview of what flexibility you get, basically cost, operation, performance. This is a very new proxy written in Rust, which is it's more it's a very scoped proxy, so they haven't put additional stuff into it. So it does only L3 and L4, nothing more, nothing less,
Gotcha.
just those two. So it's very scoped down to the part where it's only doing that, and then they have put L7 in the waypoint, and that can be configured accordingly. That depends on the application.
Makes
So
sense.
yeah, this is how the Z tunnel is visualized. Basically, you have your CNI, you have Swiffy as a identity management. So your app will have an identity that will be trust here, and then it will send the traffic to this Z tunnel. And if there's a waypoint proxy, then a waypoint proxy basically, and to another node Z tunnel, and then to the app. But there is also something called as impersonation. So what happens is sometimes it the ztunnel will impersonate basically. So if your app has an identity A,
Mm-hmm.
ztunnel doesn't have that identity, right? So ztunnel will impersonate that identity and send the traffic to the next
Gotcha. Like
hop
they'll
basically.
stimulate whatever the identity it got or it
Yeah.
has.
The only drawback is that the connection between app A
Uh-huh.
and ztunnel, that won't be encrypted as of now.
Oh,
So
gotcha.
within a node, the traffic will not be encrypted. I mean, if that much security is required, then sidecar proxy is the best approach. But if you're okay with letting your app A talk to cTunnel transparently without any encryption, then this is a very good way. Yeah, this is the connect tunnel that I was talking about. So this to this is like entirely done over the connect protocol. So it's like a proxy protocol that uh, forward proxies and reverse proxies use, where you just create a bidirectional tunnel basically. So you don't have to keep terminating the connection every now and then.
Gotcha.
And yeah, this is the Edgebone protocol used to connect nodes. So any workload you add, basically any workload to your cluster, you will have a Z tunnel, and the Z tunnel will basically connect over this HTTPS connect protocol. And this thing is called Edgebone overlay, basically
The
HTTP based
encryption
overlay
is
network.
only between the H bone, like from C tunnel to Z tunnel. Only like in the H bone overlay, I can see the encryption part.
Yeah, so this MTLS happens like here. So one Z tunnel to this Z tunnel will be fully
Hmm.
encrypted, and they'll use this connect protocol to connect basically.
Gotcha. Understood.
And yeah, this is where I announced that Ambient is beta in 1.22. So the data plane is beta, and you can read about it if you scan this QR code here. You can basically read this article. This is the official STO article that was released on May 13th, like just last week or so.
So one interesting question that I have is, since we are mentioning sidecar-less approach with the ambient mesh, right? uh, in the last couple of, I could say last from last year, like since early 2023, EBPF have been getting more popularity, right? Can EBPF be used as a service mesh? Like it
Uh,
will also go with the sidecarless approach, I think.
yeah, you can definitely. There are like a lot of people trying to, even like I know one person who has implemented DNS within eBPF. So it's like a transparent DNS server. It runs within the kernel. But
Mm-hmm.
I cannot say how much of a difference it would make, in the sense that since everything is in the kernel, basically be in memory also,
Right, right.
and so with that you will have to take care of different other things with it. But it is possible, like for example Cilium is there, right?
Mm-hmm.
Cilium uses eBPF in a lot of things to sort of observe and like route traffic and all within the service mesh, right?
Right,
So
right,
what we do is usually we use Cilium with Istio as one. So what we do is we use Cilium's CNI capabilities, and using that you can have encryption between applications, and you can use zTunnel to encrypt between nodes, basically.
right,
So
right.
it is very much compatible. Like Cilium and Istio together is like a recommended solution, I would say. So
Power
many
duo kind
many
of
of
thing.
us, yeah, it's like best of both worlds, I would say. Like the CNI with Cilium is like really performant and battle tested, and then you have the service mesh capability with STO. But I also know that Cilium can act as a service mesh, from what I have seen. Like both are
Um,
possible.
so, as far as I am aware, yeah, Cilium is itself working as a service mesh. Rather than the eBPF as a service mesh, Cilium acts as a service mesh.
Yeah, yeah, yeah. So both is like both are possible. It just depends on what the needs are basically of people
Right.
applying it. Like there will be some features, maybe it's already present in Cilium. You could just use that. And then what you have with HTO, you could just complement it with Cilium CNI. But it all depends on the use case, to be very honest. Like having both together in the service mesh is definitely like beneficial in the way that it
Mhm.
works right now. But never know how the future is. Could be like, both service meshes could exist at the same time, and then you would have different people coming up with different use cases for it.
Gotcha. Gotcha. Uh, so those were all the questions from my side. Um, Thank you, Leon, for your time
Yep, no worries.
for coming up and like letting us know more about the recent update with Istio Ambient Mesh. The beta version, they are ready for production. They are ready for to be used in production. The beta parts, and like what's the difference between Cilium service mesh, normal service mesh, and then the ambient comes in, and how the Istio has, I would say, pivoted or eventually added extra properties with the ambient. It used to
Yeah,
provide a lot of with sidecar approach, but how it is working without sidecar is definitely was definitely a interesting topic.
yeah. This is an article that we've written like from Solo. If you scan this, it will just take you to the article link. But
Sure.
but yeah, we are all sort of excited to see where ambient goes in the long run. Like now, since it's in beta, that means
Mm-hmm.
more consumers basically will start deploying it in production.
In the
Maybe
production.
small, yeah, maybe smaller consumers or larger consumers, and then depending on that, we'll figure out where it goes.
Gotcha. Gotcha. That's all.
But yeah, yep, that's it.
Cool. Thank you for your time, Leon. And
Yep,
I'll see you
thank you
guys
for hosting.
in new episode. Have fun, everyone.
Yep,
Bye.
thank you for hosting me. Bye.